Good morning, my dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. We are talking about and we are studying about the space physics. In this video, we are going to talk about the supernovae and we will talk about the black holes, we will talk about the neutron stars, we will talk about the pulsars and nebula, the Milky Way, and the quasars. So let's start first of all with the supernova. Supernova is the final gigantic explosion of a supergiant star at the end of its life. The supernova lasts for just a week or so, but shines as brightly as a galaxy of 10 billion ordinary stars. Supernova occurs when a supergiant star uses up its hydrogen and helium fuel and shrinks. This boosts pressure in its core enough to fuse heavy elements such as iron. When iron begins to fuse in its core, a star collapses instantly, then rebounds in a mighty explosion. Since 1987, supernova 1987A was the first viewed with the naked eye since Kepler's 1604 sighting. Supernova remnants leftovers are the gigantic cloudy shells of material swelling out from supernovae. The supernovae seen by Chinese astronomers in AD 185 was thought to be such a bad omen that it sparked a revolution. A dramatic supernova was seen by Chinese astronomers in 1054, creating the Crab Nebula. Elements heavier than iron are made in supernova. Many of the elements that make up the human body were forged in supernovae. A supernova looks like a bright new star. The last one seen in the Milky Way was more than 400 years ago. Black holes. Gravity is so strong in black holes that it sucks everything in, including light. If a human fell into a black hole, they would stretch like spaghetti. When a star or galaxy becomes so dense that it collapses under the pull of its own gravity, black holes are created. Black holes may exist at the heart of every galaxy. Gravity shrinks a black hole to an unimaginably small point called a singularity. Around a singularity, gravity is so intense that space-time is bent into a funnel. Matter spiraling into a black hole is torn apart and glows so brightly that it creates the brightest object in the universe. Quasars. The swirling gases around a black hole turn it into an electrical generator, spouting jets containing electrons that are billions of kilometers out into space. The opposite of black holes may be white holes, which spray out matter and light into fountains. Black holes and white holes may join to form tunnels called wormholes. The gravity of a black hole is so strong that nothing can escape, not even light. Planets, stars, gas, and dust are pulled into the hole. Neutron stars, mainly made up of neutrons, neutron stars are incredibly small, super dense stars with a solid crust made of iron and similar elements. Although neutron stars weigh as much as the sun, they are just 20 kilometers across on average. A tablespoon of neutron star would weigh about 1 million tons. Neutron stars form from the central core of a star that has died in a supernova explosion. A star must be more than 1.4 times as massive as a medium sized star, such as the Sun, to produce a neutron star. This is Chandrasekhar limit. A star more than 3 times as massive as the Sun would collapse beyond a neutron star to form a black hole. This is called Oppenheimer-Volkoff limit. The first evidence of neutron star came when pulsars were discovered in 1960s. Some stars giving out X-rays, such as Hercules X1, are neutron stars. The X-rays come from nearby stars as material is squeezed onto their surfaces by their gravity. Neutron stars have very powerful magnetic fields, billions of times stronger than the Earth's, which stretch the atom out into frizzy whiskers on the star's surface. Neutron stars are tiny, super dense stars that form in supernova explosion when a star's core collapses within seconds under the huge force of its own immense gravity. That is the neutron star. Pulsars. A pulsar is a neutron star that spins rapidly, beaming out regular pulses of radio waves. The first pulsar was detected by Cambridge astronomer Jocelyn Bell Burnell in 1967. At first, astronomers thought the regular pulses might be signals from aliens, and pulsars were jokingly called LGMs, little green men. Most pulsars send their radio pulses about once a second. The slowest pulse only every 8 seconds, and the fastest every 1.4 milliseconds. The pulse rate of a pulsar slows down as it gets older. The Crab pulsar slows by a millionth of a second a day. More than 1,500 pulsars are now known, but there may be 100,000 active in the Milky Way. Pulsars probably result from a supernova explosion. That is why most are found in the flat disk of the Milky Way, where supernova occur. Pulsars are not found in the same place as supernovae because they form after the debris from the explosion has spread into space. With much rapid pulses, pulsars must be tiny neutron stars. Anything larger could not spin as fast. The Crab Nebula contains a pulsar also known as PSR BO 531 plus 21. It is one of the youngest pulsars and it probably formed after the supernova explosion seen in the Crab Nebula in 1054. It has a rotation period of 0.0331 seconds, but it is gradually slowing down. So this is about the pulsars. Nebulae, any fuzzy patch of light in the night sky once was once called a nebula. Nowadays, many of these are known to be galaxies instead. Nebulae are gigantic clouds of gas and space dust. Glowing nebulae give off a dim red light as the hydrogen gas in them is heated by radiation from nearby stars. The Great Nebula of Orion is a glowing nebula just visible to the naked eye. Reflection nebula have no light. They can only be seen because starlight shines off the dust in them. Dark nebula not only have no light of their own, they also soak up all light. They can only be seen as patches of darkness, blocking out light from the stars behind them. The Horsehead Nebula in Orion is the best known dark nebula. As its name suggests, it is shaped like a horse head. Planetary nebula are thin rings of gas clouds that are thrown out by dying stars. Despite their name, they have nothing to do with planets. The ring nebula in Lyra is the best known of the planetary nebula. This glowing nebula, the Trifid nebula, glows as hydrogen and helium gas in it is heated by radiation from stars. The Milky Way, the faint hazy hand of light that can be seen stretching right across the night sky, is the Milky Way. With binoculars, the countless stars that make up the Milky Way can be seen. The Milky Way is the view of our galaxy from Earth. The Milky Way galaxy is one of billions in space. The galaxy is 100,000 light years across and 1,000 light years thick. It is made up of 100 billion stars. All the stars are arranged in a spiral with a bulge in the middle. The sun is just one of the billions of stars on one arm of the spiral. The Milky Way is whirling rapidly, spinning the sun and other stars around at 800,000 kilometers per hour. The sun travels around the Milky Way once every 220 million years, a journey of 170,000 light years. The huge bulge at the center of the galaxy is about 20,000 light years across and 3,000 light years thick. It only contains very old stars and little dust or gas. There may be a huge black hole in the very middle of the Milky Way. So this is the Milky Way. Then we have galaxies, giant group of millions or even trillions of stars are called galaxies. Our own local galaxy is the Milky Way. There may be 500 billion galaxies in the universe. Only three galaxies are visible to the naked eye from Earth beside the Milky Way: the large and small Magellanic Clouds and the Andromeda Galaxy. In 1923, astronomers first realized that galaxies are huge star groups. Galaxies are often found in groups called clusters. One cluster may contain hundreds of galaxies. Spiral galaxies are spinning galaxies with a dense core and spiraling arms. Irregular galaxies have no obvious shape. They may have formed from the debris of galaxies that crashed into each other. Elliptical galaxies are vast, old, egg-shaped galaxies made up of as many as 1 trillion stars. Barred spiral galaxies have just two arms. These are linked across the middle of the galaxy by a bar from which they trail. So here you can see spiral, irregular, elliptical, spiral with a bar through the middle. There are various types of galaxies in the universe. Although they are vast, they are so far away that they look like fuzzy clouds. Quasars, the most intense source of light in the universe. Quasars are no bigger than the solar system, but they glow with the brightness of 100 galaxies. Quasars are the most distant known objects in the universe. Even the nearest is 1 billion light years away. The most distant quasi is on the very edge of the known universe, 13 billion light years away. Some quasars are so far away that we see them as they were when the universe was still in its infancy, less than 10% of its current age. Quasi is short of quasars is short of quasi stellar star-like radio source. This comes from the fact that the first quasi were detected by the strong radio signals they give out, and also because quasars are so small and bright that at first people thought they looked like stars. Less than 10% of the 100,000 quasars now known actually beam out radio signals. The brightest quasars 3C273 is 2.5 billion light years away. Quasars are at the heart of some galaxies called active galaxies. The energy used by quasars comes from a black hole at their core, which draws in matter furiously. The black hole in a quasars may have the same mass as 100 million suns. The Hubble Space Telescope has taken photographs of quasars including PKS 2349 billions of light years away. Constellations. Patterns of stars in the sky are called constellations. Astronomers use them to pinpoint individual stars. Most of the constellations were identified long ago by the stargazers of ancient Babylon and Greece. Constellations are simply patterns. There is no real link between the stars. Astronomers today recognize 88 constellations, heroes and creatures of Greek myth, such as Orion and Perseus, provided the names for many constellations, although each name is usually written in its Latin form, not in Greek. The stars in each constellation are named after a letter of the Greek alphabet. The brightest star in each constellation is called the Alpha star, the next brightest Beta, and so on. Different constellations become visible at different times of year as the Earth travels around the Sun. Southern Hemisphere constellations are different from those in the North. The constellations of the Great Bear, also known by its Latin name, Ursa Major, contains an easily recognizable group of 7 stars called the Plough or the Big Dipper. So, this is about the constellation, and then we have celestial sphere. Stars seem to move across the sky as though they are on the inside of a giant ball. This is the celestial sphere. The northern tip is called the North Celestial Pole. The southern tip is the South Celestial Pole. The celestial sphere appears to rotate on an axis that runs between its two celestial poles. There is an equator around the middle of the celestial sphere, just like Earth. The positions of the stars on the celestial spheres are given by their declination and right ascension. Declination is like latitude. It is measured in degrees and shows a star's position between the pole and the equator. Rough ascension is like longitude. It is measured in hours, minutes, and seconds and shows how far a star is from the first point of Aries. The zenith is the point of the sphere above a person's head as they look into the night sky. The celestial sphere is like a great blue ball dotted with stars, with the earth in the middle. It is imaginary, but makes it easy to locate stars and constellations. So, number one here, that's the north tip. This is the south tip. This is the equator, declination line, and this is the declination line, and the right ascension line. This is the right ascension line. So this was about the celestial sphere. So that's about the star charts. So I think this is the video has already been so long. So I hope that you have understood something about the supernova, black holes, neutron stars, pulsars, nebulae, the Milky Way, and the quasars, and celestial spheres, constellations, and the different shapes of the galaxies. So I hope that this video will be helpful to you, and I suggest that please watch more and more videos and documentaries on this topic. The more you will watch the videos, the more your concept about the space physics will open up. So thank you very much. Have a good day. God bless you all.